Bismillahirrahmanirrahim. Once again, Rabbi Shadi Sadri wa Yassirli Amri wa ala Luqdatam min lisani yafqahu qawli. Rabbi zidni ilma. May Allah make our life easy. Okay, now we are starting our paper 1, chapter 1. The topic is written there. So, can any one of you tell me actually, do you understand anything of these three like terminologies, binary, hexadecimal, and denary? Yes. Anyone has anything to say regarding these terminologies? Yes, children. I'll come to the term systems later, but right now I'm concentrating on the term binary. So anyone has any idea about the term binary? What is binary actually? Or maybe hexadecimal? Do you know how, okay, now perfect binary means 2. Yes, because bi is actually 2. So binary means something that is dealing with 2 values. That is why we call it binary. Okay, anything else that you have to say about it? Apart from Zainab, anyone else has to answer? You can answer in the chat window. You can unmute yourselves and then speak. Both options are available to you. Children. Okay, hexadecimal. Anything come into your mind when you read this terminology? Hexadecimal? Okay, binary is made up of 1 and 0. 6 decimal. Okay, perfect, Barira. Yes, it's no problem. Like what I said in the beginning, you only have to answer. No one has, like, I'm the person to tell you that whether your answer is right or wrong. But as far as the learning is concerned, you need to speak. Okay? So hexa is actually hex. You must have read hexagon, a six-sided figure. So here hex means the same. It's basically 6, and decimal is actually 10. So here it means 16. What it is, we will come to know about it inshallah very soon. Now moving on to the binary system. What is binary system? It is basically a number system that we are talking about with respect to the computer. It's basically a 1 and a 0. By the way, a 1 and a 0, like an example I'm quoting. If I am active in the class, I'll say I'm a 1. If I am inactive in the class, not in the right mood of studying, like mujhe neend aa rahi hai, mujhe boriyat ho rahi hai, whatever, something like that, then I can say I'm a 0. So let's see how many of you are a 1. Just raise your hands quickly. The ones, raise your hands quickly. Let me see. Out of the 15 participants, how many are 1s? 5, 6. Only 6 are 1s? 7 1s? What about the others? 8 1s? Then the rest are a 0. Are the rest a 0? Okay, that's wonderful. 11 are 1s. 12. Then who else is a 1? Is there anyone who is not a 1 right now? Okay, you can either have a thumbs up or raise hand, whatever you want to. But I have 14 participants out of 16 who are showing a thumbs up or a hands up, which means that you are a 1. A 0 means that I'm off. Okay, now, can you any other examples striking your mind regarding this? 0.5. Okay, now please either very quickly become a 1. I enjoy your answer, but basically in the Denary there is no 0.5, Sakina. Okay, now that's a really interesting class. I hope that after class you will say that we all are a 1. We know none of us was a 0. Well, now thank you very much. You can lower your hands now. Thank you very much, children. Besides this, what else is your denary or decimal? Sometimes we hear the term decimal, sometimes we hear the term denary. So these both mean that it's basically a number system that is dealing with how many digits? These are 10 digits. So this is what we humans understand. We humans work on denary or decimal. And why is it like, if I talk about myself, when I am learning math, I actually am working on denary. So this is what is something that we have been doing from day 1 of my learning. I was learning numbers and I was always taught KG 1, 2, 3, 4. So actually I was taught a denary number system or a decimal number system. Okay, now, thank you, Varina. You have a question, beta? Your hand is raised. So do you have a question right now? Okay, thank you very much. Okay.
Oh, sorry, miss.
No, it's okay. It's okay. No problem. Now, this is also given the name base 10. So base 10 is actually another name that we use for denary. And it has 10 digits, which are starting from 0 and ending on 9. Like it's 10, but actually 10 is a combination of 1 and 0. And then it is going to be worked upon by multiplying the value by the digit position. So this is what we actually work. So a very brief discussion about okay, what the denary number system is. Any query regarding denary? I talked about three, 4 points about it. We humans understand this is the base 10 containing values from 0 to 9. And these are the three basic principles. And how do we find it out is mentioned that we find out the value by calculating with multiples of 10, with multiples of 10 or powers of 10, 10, 0, 10, 1, like that. So is that clear? Maybe move ahead. Yes, children, maybe move ahead. Any query?
I don't understand the last point.
You are questioning about the last point, Zainab. The value of each place is calculated by multiplying by 10. Like for example, if I say 20, so 20 means units is, or if I say 25, so what will be your answer? What is units and what is tens?
Units is 5 and tens is 2.
Exactly. If I ask you to show it with some calculations, so you will say 5 into 1 plus 2 into 10, isn't it? Will you say the same thing? So what is it actually? You are actually multiplying units by power 0 and tens by power 1. So this is how we carry on further. When I'm moving on from the right hand side to the left hand side, the same principle we are going to do it here as well as calculation the concern. So you always start from the right hand side and then we move on further towards the left hand side, which is units, and then tens and hundreds. We move on and like this. So this is basically mentioned here. So my objective will be explained once I move on to the conversion thing. Then you will be able to, I guess, understand a little better. Okay? So you are going to find it out. I hope that you have understood. I said 25. So you said 25, but actually 25 ka matlab means units place is 5 and tens place is 20. In reality, it is 20. That is why you got 20 plus 5 equals to 25. Agreed? This is what we normally do. So this is basically written here by multiplying by the powers of 10. So powers of 10 ka matlab, first power will be 0, then power 1, then power 2. Likewise, it goes on, it increases. But the first value is a 0. 10 power 0, 2 power 0, 16 power 0, likewise. Anyone has any other query before I move on to the next topic? Thank you very much, Zena, for asking the question. Yes, anyone else has any query, Vita?
Yes, I wanted to ask, like, denary is like unit and tens.
Exactly. Actually, the one that we humans understand is basically denary. And when I talk about us, we learn denary in this manner. We say units and then tens and hundreds and then thousands. It goes on and on like this, isn't it? This is basically something that we are already aware of. We are already using it from our childhood. We are learning. When I say after 9, I learn 10. I learn 11. So this is basically units and tens. Although we don't learn it at that time, but once you are going to work on the conversions, then you'll be able to understand yourself that this is how we are doing it as humans as well. Okay. Okay. Am I clear? Okay. Now let's move on to binary. What is question? What my question was raised earlier. The same is now written, and I hope that you are noting this down as well, because I want to share one question that came in one of the past papers. That was dealing with the, like, this is again very important. We need to understand and we need to learn how to answer. So the main trick is a lot of people know, but they don't know how to answer, and then they are not able to score. So our objective is learning as well as scoring. So our objective should be two-folded. So I hope that you are understanding. I remember once they have a question as KG, the comparison between denary or binary and denary and hexadecimal. So you need to be well aware of how this is being done so that you can answer the questions whenever they come in the paper. You can compare them. So this is binary, and you can see the features. It's basically the number values are unique digits, which are 0 and 1. This is what a computer works on. This is the basic building block. And most of the computing devices use binary number system. And then like on and off. By the way, I was expecting, by the way, is there any other thing that I can relate to with respect to binary? Yes, children? Can I relate to something else that is dealing with binary? Yes, with 0 and 1. Your switches. If I say a switch is either on or off. Do you agree with this? A switch is either on or off. So this on or off means it is actually working on binary. This is not two value. This is one value, which is a 0 or a 1. So I guess the best example of you can say binary is going to be your switch. Okay, the switch that we actually work on is the best example of my binary. Okay, children. So I hope that you have noted this down. Are you all a 1? I hope so. No one is a 0. Yes, are you all a 1?
Yes, miss.
Okay.
Yes, miss.
Okay. Being a physics student, you must be familiar with voltage off, voltage on, current or voltage. These are certain things that we encounter in physics as well. We study off means a 0 and on means a 1. And the another one is, it is called base 2. And you can see base 2 is given, the name is given as base 2 because it's dealing with two values which are 0 and 1. Okay. Yes, you better write it down in the journals for your own sake. If you want to, it's going to be a better thing. If you note down the chapter number is 1, you note down the binary number system, its features, the 4 features mentioned here, that what are they working on? They are working on, they are the principles for computer science. Computer systems are working on zeros and ones. And then we have, okay, Zainab said 1 because you are a 1, I guess. Now, no queries regarding this. I'm moving on to the next one, but that is dealing with hexadecimal. And that is something that you can understand very easily yourself. Okay. Now, this is what the question that was raised earlier by some child. I guess that now your question, your query will be answered, like regarding the base 10. I said it will be powers of 10. Here you can see, by the way, children, I just want you people to be a little attentive. No problem at all. Maybe you will take a little time to understand. By the way, have you people studied this conversion in any of your junior classes as a theory topic? Yes, have you people ever learned? Yes, children?
In maths.
In maths, okay, fine. If you must be familiar with the conversion, definitely 2 power 0, 2 power 1, 2 power 2 likewise. And remember one thing, one principle that you need to remember, anything raised to power 0 is always equal to 1, no matter what it is. If it's power 10, it's base 10, it's base 2, it's base 16, or it's anything. So you need to be very much aware. Okay, anything raised to power 0 is always equal to 1. Okay, then we move further. We have 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, and 2 power 7. Now, I'm using a term, byte, B-Y-T-E. Are we aware of this term, byte and bit? We all must have heard about it. Megabytes and terabytes and this and that. So can anyone of you tell me what is actually a byte and what is a bit? Gee, have you ever heard this term? Children, I want to have an interactive class. I don't want to see a class which is sleeping. I want to have a class full of ones. Yes. Excuse me, may I please know the answer? What was the question that I had raised?
This is it byte or bit?
Exactly. So have you ever heard this term? I'm asking, have you ever heard? Yes, exactly. Thank you, Amna. I don't want you, maybe, I just wanted to know better that do you people know these terminologies or not? So you may have heard about GB and terabyte and megabyte.
Yes.
Yeah, exactly.
Yes,
So,
yes.
uh, Ji, Barira, may you please say it again, beta? I could not hear because of the someone else saying it.
No, I said yes, I've heard this term.
Okay, fine. So what is it actually? Now let's see it from here. It's, if you just pay attention to these values, these are basically, this is a byte, and a byte has bits. How many bits are there? There are 8 bits. So I can see it's basically a whole byte composed of 8 bits, which are starting from the right hand side. Their numbering is starting from the right hand side, and then they move further, and then they move end here, which is 2 power 7. You can see there are basically 8 bits, and these 8 bits together form a byte. Do you want an example for this? I can say my hand, my foot, my eyes, I1, I2, my nose. These all are a part of my body. So I can say my body is basically a byte, and this has different bits. So I hope that I'm clear about it. Yes or no? Zainab has written a very
Yes.
correct answer. So you can see how many bits are there in one byte. There are 8 bits. And this is, bit is the smallest piece of information a computer can store. So this is what is the definition. And as far as the GB and other things are concerned, they are actually like the smallest is byte. And then we move further, we have a kilobyte, then we have a megabyte, then we have a gigabyte, and then we have terabyte, and the list goes on. We have more and more, but we start with a byte. Smallest thing is a byte. Am I clear? So we have 8 bits, and these 8 bits are representing a certain value. And what are they? You can see 1, which is 2 power 0. 2 power 1, recall your math. What is 2 power 1 equal to? Yes, 2. That is why 2 is written here. What is 2 power 2?
4.
4. That's why 4 is written here. What is 2 power
4.
3? 2 power 3.
8.
Isn't it 6?
8.
Isn't it 6? Isn't 2 power 3 equal to
Almost
6?
2 3s are 6,
No.
but we will multiply 2 3
2
times.
time multiplies.
Exactly. Why am I
Yes.
saying this? Because many times I have seen good students, even good students mean that the one who are very cautious, even they make a small mistake, and then they maybe in haste or in confusions or whatever, they make a mistake and they say 2 power 3 equals to 6. So that is why I said this. I asked for it right now that 2 power 3 means it is going to be 2 into 2 into 2, that makes it 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. So it means that if I work on this, I will be getting a complete byte, and what can be stored will be coming, inshallah, next. Any ambiguity, any questions from this topic? Yes, children?
Yes, miss, but what is the use of bits?
What is the use of
Like,
bit?
why do they have bits?
Why do they have bits? What is the use of my hand? What is the use of my eye? They all have a function to perform. So similarly, bits also have a function to perform. Like, for example, if I say, okay, if you all allow me, then I'm going to move on to a topic that I'm planning for a little bit later. But right now, if you just say every bit has a certain value, you can say, assume that, okay, now I'm saying it right now. I hope that you will understand and you will be answering. Is my pace okay? Is my voice okay, children? Are you all comfortable with my
Yes.
voice and my pace? Any problem
Yes,
with
yes.
my, are you all a 1 right now? Is there any 0? Is there
Yeah.
any 0.5? Is there anyone who is a 0 right now, or a 0.5? Was just logged
It's
in
a
and
0.5, but not 0.
Achha, okay. But I request you people to become a 1 immediately. Now moving on to this one. What I said, assume that I have to turn on one bulb. Assume that these are different switches. Please remember, This is switch number 1, switch number 2, switch number 3, switch number 4, 5, 6, 7, and 8. If, for example, I was supposed to turn on one bulb only, which switch will I turn on? Which switch will I press? Switch number. I will press the first switch, which is 1, because this switch is meant to turn on one bulb. If, for example, I move further, I say this is switch number 2, that is going to turn on 2 bulbs. So if I have to turn on 2 bulbs, I'll move on and will click and will switch on the second button. So in this manner, I'll work and then I'll be moving further. Like definitely this is going to be coming next, my next topic. But since you asked, that is why I have said right now, maybe that will be a little confusing for some of you. So let's leave it for the next topic, which I definitely have to do with you people today or maybe some other time. Okay, now hexadecimal. This is basically 16 values. And you can see 0 to 9 is the same as was in Denary. And then we have one more difference, and that is for 10, we say A. Like for example, right now, if I have 16 participants, if there were, for example, 14 participants, so instead of 14, I will say I have E participants. If there are 15 participants, I will say there are 15, or F participants, like the 16th one has come. Now 17th one has come. So this is what is actually the representation of 10, 11, 12, 13, 14, and 15 in hexadecimal. So this is what we do. Okay, so this is how we present. We actually present the values. A means 10, B means 11, C means 12, D means 13, E means 14, and F means 15. Is that clear? And this is again a number system, which is the number system of computers. Computers work on binary as well as hex. Okay, any confusions from this hexadecimal, or should I move on to the conversion part? Yes, children, any confusions? Should I move ahead? Okay, this is my topic for today. Assume that I was asked to convert a number 107 into binary. So what will I do? This is something that you can see here. Okay, now children, just pay attention. If you're facing any problem, then you can actually raise your hand or raise your concern. But right now, I'll explain this topic maybe twice or thrice. So just concentrate. It's very easy. Believe in me, it's very, very simple. I'll move on to the same as I was explaining you earlier. Any problem faced by anyone? Are you all here? Are you all in the mood of doing the questions once I'm through with explanation? Are you all with me, children?
Yes.
Yes.
Okay. Okay. 107. If I just say, remember what we saw earlier, we talked about the, I'll move back to the same slide that we showed earlier. Remember this thing. I hope that you have all noted down. 2 power 0, 1, 2 power 1, 2 power
Yes,
2,
miss.
3, 4, 5, 6, 7. That's wonderful. Then we move on and write down their values, which are 1, 2, 4, 8, 16, 32, 64, 128. I hope that you have written down these things. And now moving on to the question once again.
So miss, we'll put 1, which means on.
Exactly.
It'll sum to 107.
Exactly, Barira. This is what is the objective. So you have got to the point. I hope that the others I'll explain. No problem, no worries at all. But just relax yourselves and enjoy. I say 107. I know the values that the first bit represents 1, second bit represents 2, third bit represents 4, 8, 16, 32, 64, 128. Any problem, any ambiguity with this first line? No? Okay.
No, miss.
Okay. Since the value is 107, so I'll start from this side and I'll see, will this 128 be occupied? Because the value 107 is smaller than 128 is smaller than 107. So definitely that will not be turned on. What I will do is I will place a 0 here, because it is not going to be turned on. It is not included. I hope that you can understand. Now, what I did was I next did worked on 64. So 64 will definitely be turned on because of the reason this is smaller than 107. You keep on comparing with the value that is given to you as a question, and then you see kg 64 kya hoga, definitely that will be turned on because I need to have 64 to make up 107. In order to make 107, 64 is needed. Any ambiguity with this? Any problem with this? Yes, children, through with this? 64 is the basic thing I did. And then what I did was I moved ahead. Then 32. Should 32 be included? Because 64 and 32 together makes how many?
96.
96. So definitely 96 is going to be a value lesser than how many of you? Yes, yeah, definitely I will repeat, Zainab. I was working on 107 and 107 is definitely smaller than 128. Do you all agree? So since it is smaller
Yes,
than
miss.
128, then definitely this bit will be turned off. This bit will not be needed. Then I moved on further. I turned on this bit, means that since this bit is representing 64, that is smaller than 107, that is why this will be here. Then I moved further. I said 32. 64 and 32 together makes 96. So that is why I had turned on these two switches so that it will come to the answer of 96. Any problem in understanding these three bits working?
No, miss.
Yes, anyone has any problem? Amna has said no, miss.
Yes,
Others?
Miss, can you explain it again? Like I have a little bit of confusion.
From the beginning or just right now? I said
No, from the bits.
from the, okay, now 107 was my question. 128 is definitely not going to be included. I hope that this is what we all have agreed. Have you all agreed upon this thing? Yes or no?
Yes, miss.
Okay. Now moving further, what I did was I moved on to the next value, that was 64. So 64 will definitely be turned on because 107 is bigger than 64. Then after 64, I looked at 32. So should I have 32 also turned on? What I did was I added 64 and 32 and I came up with the answer of 96. So since 96 itself is smaller than 107, then what I did was I turned on the two bits which are representing 64 and 32. Am I clear?
Yes, miss.
Okay.
Thank you.
Most welcome. I hope that no ambiguity with anyone, because then after this we are going to do some practice questions in the class. So 64 and 32 is 96. How much is left? Come on, quick. 107 minus 96. Come on.
10,
Math.
miss.
10 or 11?
11.
11. So what will I do? Will I go for this 16? Will I go for the
No.
16? No. That is why I have placed a 0 here. Should I go for 8?
Yes.
Yes. Should I go for 4? No, because 8 and 4 is 12. I don't need this 12 and I only need 11. So which bits are going to represent 11? So that is what I
2
need
and
to
1.
see. I will be ticking this bit 8. I'll be taking this bit 2. I'll be taking this bit 1. And here it completes my 107. Is that clear? So if I add up, you can see yourself. And please remember, calculator is not allowed. That is why if you add it up mentally, orally, you will come up with the final answer of 107. Because if you add up 64 and 32 and 8 and 2 and 1, so you will get an answer of 107. Is this clear? Yes or no? Any problem faced by anyone, children? I mean, this is an interesting
miss.
topic. This is an interesting topic, and believe in me, this question nearly comes every time. Like I can't recall a single year when something related to this topic hasn't appeared in our papers. So this comes every time. So may I move ahead to the next practice question? Anyone wants me to explain it again? Because we are left with 8 minutes, and then our next session will be starting. Definitely, you must have some other session. So may I move ahead? Now, this is another method. If you have understood this well, that is what is recommended by the CIE, but otherwise, this is another method that we we can use, but the one that I explained earlier, that is the recommended method. So those of you who are able to understand the first one, that is more than good. Okay, ji? Now moving
Is
on
the
to
1 and 0 1 are already given in the paper, right?
no. We are given the whole byte. Like, let me show you the earlier question. We are given actually this whole byte, and it's all blank. And I'm asked to fill in the blanks to complete the value that is given to me in the question. Like, for example, maybe 107, instead of 107, they will give me 15. They will give me 55. Okay, let's do a practice. Let me ask. If I have to work on 15, 1, 5, so can you quickly tell me which bits together comprise or make 15? And this should be coming very quickly from your end, children. Yes. 15. I want to make 15.
Miss 8, 4, 2, and 1.
Exactly. Thank you very much. Anyone else has also come up to the same answer? Because if you quickly add up, 8 and 4 is 12, 12 and 2 is 14, and 14 and 1 is 15. So are you all able to do it?
Yes, miss.
Is my pace okay, children? I keep on asking you because it's my first class with you people. Any queries, anything that you have, you can definitely ask me. There's no problem with that. So if you're through with this, then I'm going to move on to the next activity, which I want you all to do. Let's see. I will suggest you people to go for that thing which I did here. 86. 15 I did, 107 I did. Now I expect you people to do 86. May you start doing it quickly. Make the same pattern, which is 1, 2, 4, 8, 16, 32, 64, 128. Any query that you have, you can ask me, unmute yourselves and question, write in the chat window. I'll be in a position to answer. Come on, start doing 86.
Then Miss.
Yes.
Miss.
Gigi,
I've done.
done? Excellent, excellent. Let others also do it. Yes, I'm waiting for others also to come up with the same. Miss, we have done it. Okay, now. That's wonderful. Terim also correct. Okay, now Terim, you are correct. That's wonderful, Terim. Children, very quickly, please. We are left with 4 minutes only. I hope that we all are through. Okay, now Zainab is also written answer. Okay, now let's see the answer, and let's give ourselves a thumbs up, a happy face, if you have come up with the same answer as is here. Yes, how many of you we have thumbs up? Just give thumbs up to yourself right now. Yes, how many thumbs up? 3 only. What about the others? Okay, now children, since it's azan time, I am going to be I'm going to mute myself for 2 minutes, and then in the meantime there is another question. Let's do this one as well. Jicharan, are you done with the next question as well? Okay, Dania, thank you
Yes,
very much. By the way, have you all done it? Let's see the answer. By the way, what will be the answer for that?
Miss, we're going to use all of them.
Yes, exactly. Thank you very much, Amna. If I show you the working of 255, that means all the bits will be on, and that makes it 255. So is there anyone who has not understood? Please show a thumbs down if you are still facing problem. This is the last minute of our class. So I hope that you have actually learned this topic forever. Thank you very much, Tareen. Thank you very much, Dania. Thank you very much, Amna, who have answered this question. So, Betaji, any problem, any ambiguity with this? Are you all clear? Is there any thumbs down for this topic? Because I'm expecting you people to remember it for at least 2 more years. Because you have to appear in 11th, if you pursue it as a career, that will be needed in class 11th, the later years as well. So, okay, now the meeting is about to end. So, Allah Hafiz from my end, all the time, I guess, is going to be. So, nearly Allah Hafiz from my end, but still, any question that you have, you can answer, you can ask.